Welcome to Analytics with Excel. In this part of the course, we will be covering basic statistical techniques and their implementation in Excel. The sessions themselves will focus on understanding a little bit of the statistical ideas and the methodologies that go behind them, a little bit of math, though not much, and some implementation in Excel. The hope is at the end, you will be excited to dig deeper into these statistical ideas and methods, and also to explore more with Excel and possibly other statistical softwares that can build on the methods that we will be discussing. So we begin by describing data. Describing data simply means taking a column of data, calculating numbers from it that help describe what the characteristics of that particular set of data is. We'll begin with simple examples that correspond to simple univariate data, which means data that comes in one column. In it, we shall talk about several ideas, the first of which is the idea of central tendency or location. Where is the data located? If I were to use one number to describe the data, what would that number be? How can one interpret it? And what does that mean in different situations? Data, of course, exists not just at single points, but as a spread, as a distribution. This is usually referred to as dispersion or variation. And this needs to be measured. This needs to be computed. This needs to be described. So where is the data located? What single number describes it the best? How spread is it around that location? Is it highly variable? Is it not variable? In addition to that, we will deal with a very specialized notion of dispersion or variation that talks about when we compute estimates from data, for example, averages, then what is the variability of those estimates? And these two notions of variation or dispersion have interesting connections. And these connections are particularly true or valid when we include the idea of the shape of a data distribution, not just in the notion of where is the middle and what is the spread of the data, but is it tilted more to the right or more to the left? Is it skewed, so to speak? Is the distribution very sharp in the middle, or is it flat? Does it have a peak? Does it tail off, and therefore are there likely to be outliers? The shape of a distribution describes the kind of analysis that would be useful for it. And together, descriptive statistics covers the field that describes data and uses simple analytical techniques to draw conclusion from data without caring too much of the mathematical models or the probabilistic ideas that are underneath it. Those will come a little later. So let's get moving with descriptive statistics. The first measure of location that we'd like to consider is called the average. Sometimes it is referred to as the mean, which is the usual statistical terminology. A more precise terminology for it is the arithmetic mean. There are other notions of the mean, for example, geometric means and harmonic means that extend this idea. But the simplest notion is the notion of an arithmetic mean. An arithmetic mean, or the mean, is a very simple calculation. It is just the average of the data as we understand it. Take all the numbers, add them up, divide by however many numbers there are, and that becomes your arithmetic mean. We use some notations in this just to get you a little comfortable with the idea of how analysts and statisticians often tend to think of things. Letters such as x1, for example, symbols such as x1 are used to indicate variables. This means the first observation from the variable x. Similarly, x2 refers to the second observation from variable x, or the second data item in a column. Similarly, xn would be the last. N therefore indicates how many observations there are. So when we add up all the observations and then multiply by 1 over n, equivalently dividing by n, we get the average. This is indicated with the summation notation, the sigma notation, summation equal to 1 to n, that is shorthand for the sum that is written above. The sigma notation is used to make shorter expressions when we simply want to add things. The notation x bar is standard when we refer to the mean of a distribution. So going forward, if we have occasion to write x bar, we should understand that as just the average of observations. So let's see what this turns out to be in specific cases, and it also allows us to get an introduction to descriptive statistics in Excel. This is a data set. It consists of data from stores. We have data on store area, the number of items available, the daily customer count, and the sales that the store makes. This is usually referred to as multivariate data with 4 variables. For the initial session, we shall be considering the variables one at a time, simple columns. For example, we can consider the daily customer count column. The daily customer count column, if we are to summarize the information in it, requires us to compute measures of central tendency, such as the mean. For example, we can compute averages. Let's say I compute the average here. First, let me compute the sum of, say, customer counts. So if I were to compute the sum of customer counts, say in the cell below, I would write that as equal to sum, which is a function, and it would then indicate, tell me what you would like to take the sum over. So let me pull it down this column, and that indicates the variable for which I am wishing to compute the sum. So the sum of customer counts is about 80,000 over my 100 stores. If there are 100 stores, what would be the average of customer counts? Or if I may so write, mean customer count this would be the sum divided by 100, which I can also read off from the data, and gives me the number 801.1. About 800 customers on the average are visiting my stores. We do not need to do this calculation all the time. We can, of course, use the average function to do this as well. For example, I can write this as, let us say, average, and then use the same daily customer count. To reach the number 801.1 as well. So the arithmetic mean, add and divide, is simply the average of the data. As a descriptive statistics itself, this is reported out by Excel through macros or packages that Excel has prepared for us. This is visible under the Data tab in Data Analysis. If this toolkit is not available to you, what you can do is you can go to File, go to Options, Add-ins, and within Add-ins, you will see Analysis Tool Pack, which you can select. Once it has been selected, you can press OK, and it will be present in your Data tab. The Data Analysis Tool Pack contains a number of functions that we shall be using in the course of these sessions. One of these is descriptive statistics. Descriptive statistics is a set of calculations that a data set can be subjected to. Let us see what it gives us. It requires an input range. Let us say that we give daily customer count as its input range. It's grouped by column. The way the data exists, I've included data customer count in the selected cells. Therefore, I should indicate labels in the first row. It requires me to indicate summary statistics or confidence level and what are the things that I would want. For now, let's keep life simple and request only the summary statistics of the data. It will require an output range, which I can specify. In this particular case, I can, for example, specify a cell here, or I can simply specify a new worksheet, which will indicate a tab. In the sheet that has been created, this indicates the descriptive statistics for the variable that has been entered into the descriptive statistics dialog box. In my case, this is daily customer count. The mean, as you can see from here, is 801.1. which is the same calculation that we had manually obtained. So, in order to compute the mean, you do not actually need to carry out sums or averages within Excel itself. Descriptive statistics as an Excel function will give you such a number. This is the arithmetic mean. The arithmetic mean can also be represented in some way as the center of gravity of the data. If you're inclined to think in terms of data as pictures, then the center of gravity of the data reflects the point at which the data set will balance. And therefore, if the data balances around the mean, it will not tip off, so to speak, on the left or to the right. A second measure of location to be compared with the mean is what is referred to as the median. The median is the middle value of the data after it has been ordered. For example, we may think of computing the median income. What does this mean? It means arrange all the people from the poorest to the richest and identify the average person, which means the person in the middle, and then simply read off the income of the average person or the person in the middle. Half the people are richer than the median person and half are poorer. Contrast this with what the mean does, which is simply add up and divide and arrive at the so-called per capita income. As you can see, the mean will be affected by very large incomes, but the median will not be. If the richest become even richer, the average person, the person in the middle, will not change his or her income. How is the median therefore calculated? Simply sort all the numbers, x1 being the smallest and xn being the largest. For example, let us consider the case n is equal to 5, in which case I have 5 numbers. What is the middle of 5 numbers? x1 to x2, x3, x4, x5. The middle is x3, which is 5 plus 1 divided by 2. So if n is odd, the middle is n plus 1 over 2, where n is the number of observations that I have. On the other hand, if there are, let's say, 4 observations, and I have x1, x2, x3, and x4, then there are 2 middles. If there are 2 middles, what I should do, or what I can do, is take the average of the 2 middles, which gives me a unique definition of what the median is. So, what would the median be in our particular case? The median for daily customer counts can be computed, if I wish, from first principles by, for example, sorting. And how can I sort? Let's say I look at sorted customer count, which I can go to. I might as well do it here as well. So I can go to data. Let's say copy from here. To sorted customer count. Let's say here. And now I can consider these values. Go to data, sort customer count, values smallest to largest. This sorts my customer count. Where is my middle value? My middle value, this is observation 1, for example. Remember that I now have 100 observations here. So, according to my formula, what should I be seeing? I should be seeing 50 plus 51. So I need the 50th observation and the 51st observation sorted. This is the first observation, the second. So number 50 will be in row 51, and number 51 will be in row 52. These corresponds to counts 770 and 780. So if these are the two counts that are available to me, let me go back to my descriptive statistics output and see what the median is. The median is reported as 775, which is the average of 770 and 780, these two cell counts. Therefore, I can conclude from this analysis that half my customers or half my stores have less than 775 customers, and half my stores have more than 775 customers on a daily basis. Contrast this with the number that on the average, my stores have 801 customers, derived in the usual sense of average. Which number you will use depends on your expectation from the data and what question you are trying to solve. Are you asking for, shall we say, per capita customer counts, or are you asking for the count on the typical store? These are two common measures of central tendency that are used. The mean is, as you might guess, a little more susceptible to outliers and large values. For example, there are large numbers here, 1260, 1300, 1390, that extend and give the distribution a little bit of a tilt towards the right that we will talk about in a later session. Similarly, the numbers die out very quickly on the lower side. Therefore, the mean gets a push upwards because of the relative increase in high counts over low counts. The application drives the choice of central tendency measure. A third measure that we can think of, and which is sometimes used, is the mode. The mode is the most frequent value or the most common value. The value that occurs most frequently in the distribution or in the data. For instance, the modal income could be 0. What that means is more people have 0 income, in other words, do not have an income, perhaps unemployed, than they have any other specific number. The mode is not a measure of central tendency per se, because it may not be in the middle of the data. It simply represents the commonest value. So if the shape of the distribution is something like that, then the mode would be here. But a mode may or may not be calculable in a specific case. In our case, let's see what this looks like. If I simply look at the individual customer counts, 10 occurs once, 210 occurs once, 280 once, etc., most observations occur once, except, for example, 450 occurs twice. And then 530 occurs once, twice, thrice, 4 times. It occurs 4 times, as for example, does 600. So different softwares have different ways of reporting out the mode. In this particular case, Excel has reported out 530 as a modal value. What this means is that no observation occurs more frequently than 530. There may be observations that occur as frequently as 530, but none occurs as frequently. The mean and the median are calculable from the data using formulas that we have discussed. The mode, however, is a count. And if such a count does not make too much sense in the data, due to the way the data has been arranged or the way the numbers are, then the mode may or may not make as much sense. As an example, let us calculate descriptive statistics for, let's say, the sales numbers. So for the sales numbers, I will repeat what we had done before. We will again ask for a new worksheet with summary statistics. Another sheet is created in which a mean has been computed, mean sales, about 58,140, median sales of about 58,895, and no mode has been reported because no single number probably has shown up more than once in the dataset. So the mode does not make that much sense being computed in such a dataset. So while you will always see the mean and the median being reported out, you may or you may not see the mode. If it is, mean, median, and mode represent the three commonest central tendency measures, representing the average measurement, the measurement of the average unit, and the measurement of the commonest unit or the commonest measurement, shall we say. These three, taken in conjunction or taken separately as per your business need, will define what the central tendency of your data is. There are other measures of central tendency, measures that make specific sense in given contexts. For example, instead of the median, which is often or sometimes referred to as the 50th percentile, the 50th percentile in the sense that 50% is below it, 50% is above it. Sometimes other percentiles are used. For example, a 25th percentile or a 75th percentile, or maybe even a 5th percentile or a 95th percentile based on specific business or technical requirements. We will not have occasion to refer to such measures as measures of central tendency, but we will see in future sessions what measures such as minimum and maximum have to say with respect to the spread of the data, if not explicitly their location.